Okay, not a difficult question. It's certainly optional for you guys. It comes from a calculus exam that from Italy. And the exam, I say that I really can't read Italian, but you can certainly understand what they're saying over here. At least I believe you can understand what they're saying. Um, Let me just go through that with you. Certainly, I'm not going to try to pronounce that, but it looks like they're asking me to calculate this over here. And to calculate this, um, what I would do is, well, we're in the section of the notes, by the way, I'd probably make a U substitution initially. All right, let me go through that. And the U substitution I'd make would be U is equal to x plus 1. And then du would be equal to dx, right? One thing I do notice is the radicand is related to that. And let's go through that. So the radicand I'm noticing is x squared plus 2x plus 2, which is identical to x plus 1 quantity squared plus 1. All right? So I guess the first thing I'll do is just rewrite the integration as, let's put this down, 1 over, well, it's x plus 1, the u. Let's put a little star here indicating I'm making a substitution. So u squared, the root, well, then it would be u squared plus 1 and du. All right? All right, this is my first milestone in the problem. I want to point out where that's written down for you, and that's written right over here. All right. The next thing I would do, and again, I need to move backwards. I should forward and then backwards. I need to make another substitution. And what I'm going to do here is the trig substitutions now. And what trig substitution I'm going to use, let's go through this. It's going to be u equals the tangent of theta, and du would equal secant squared theta d theta. All right, let's make that substitution and see what we come up with over here. It's my second substitution now. I get 1. Well, u squared is going to be tangent squared. Let's see, I got to do this root then, right? So tangent squared plus 1, and the du is secant squared. Let's put this down, secant squared theta d theta. All right, there's some substitutions to make over here. And I do want to point out you should know identities. You should certainly know the tangent squared of theta plus 1 is the same thing as secant squared. I get secant squared d theta. I get tangent squared, and then I get the root of secant squared. Well, in this invertible region, I don't have to worry about the absolute value, so let me write this down now. And again, I'm trying to meet a milestone over here. This is secant squared theta d theta. And you're going to get tangent squared theta. And then, again, in the inverted region, it's going to just be secant theta now. All right, let's keep going. And I'm looking at this thing, I'm trying to simplify it. I would get secant theta over tangent squared theta d theta. I'm going to simplify it further. I always like to go towards sines and cosines. So I'm going to write this secant theta over tangent squared theta. Well, the secant's 1 over cosine. And the tangent squared is going to be sine squared over cosine squared. I'll just put that on top, by the way. And what do you get there? You get cosine theta over sine squared theta. All right, I'll write that down for you and see if we met that milestone now. Because I'm really at the end of this simplification here. All right, let's see if we met that milestone. And I'm looking for it. And let's see if I got that. That's right over here. All right. All right, I'm on to my third substitution now. All right. And again, some people can recognize this. I would recommend a substitution at this point. And I'm not running out of letters, but I'll make v equal I'll make v equals sine of theta now. This is my third substitution, by the way. dv is cosine theta d theta. Let's make our substitution. And again, up here, this is my third substitution, 3 stars now. And let's be careful. So cosine theta d theta is dv. And the sine theta is just v, so it's v squared. And I think I can handle that. And what's that going to be equal to? Let's take a look. Really simple now. It's v to the minus 2 dv. And this is pretty simple over here. What are you going to get over here? This is going to be, well, increase it by 1. So v to the minus 1, divide by that. Let's see, minus 1 over v. Plus my first constant of integration. All right, that's stars, by the way. All right, I got to go backwards now. And to go backwards, one step at a time. All right, let's go for that. So it's going to be minus 1. Well, what's v? It's sine theta. Now I got to remind myself. And I got to get, certainly, what am I trying to get back to? The x's. And I got to remember something about this theta problem. And I remember that the u is equal to tangent of theta. Let me write this over here. Well, we like to write this in terms of triangles now. Let's put a nice little right triangle down. And what do you get over here? It would be u, that would be 1. And this over here, the hypotenuse, would be u squared plus 1. All right, what's the sine of that angle theta? Well, let's take a look at that. You would get minus 1. I'm going backwards, right? So let's take a look. Sine would be u over the square root of u squared plus 1 plus this. Going backwards. Let's keep rewriting it. And that's going to be the square root, well, minus the opposite, u squared plus 1 over u plus, all right, I got to figure out what the u is now. Something I can't remember. It's written down. It's x plus 1. Let's write that down now. So what do you get over here? Minus x plus 1 squared plus 1 over x plus 1 and then plus c. Let me clean that up a little tiny bit, and then we'll look at the k. X squared plus 2x plus 1, which is plus 2, over x plus 1 plus some constant of integration. And I think I'm done. Let's check the key, see if we got there. Did I get this? I got this. I got this. I got this. And I got this. We're doing okay. Thank you.